Welcome back. This is Cambridge International Education. Subject is Mathematics, Paper 4, also known as M1. Session is October-November 2023. Subject code 97009, paper variant 42. Question number 1. A block of mass 15 kg slides down the line of greatest slope of an inclined plane. The top of the plane is vertical at a height of 1.6 meters above the level of the bottom plane. The speed of the block at the top is 2 meters per second and speed of block at the bottom is 4 meters per second. Find the work done against the resistance to motion of the block. So consider this scenario that the block is at the top and moves with the speed of 2 meters per second, and when it reaches the bottom the speed is 4 meters per second and the vertical height is given, which is 1.6 meters. So at the top the block has two energies, that is potential energy due to height and kinetic energy due to speed. And when it reaches at the bottom, potential energy is 0, so we're not writing that. That is kinetic energy. And some of the work is done against the resistance, which is known as work out or work done against resistance. So potential energy is mgh, kinetic energy is half mv squared, kinetic energy half mv square, and work done against resistance. Just plug in the values. Mass given is 15, gravity 10, height is 1.6. 1 by 2, mass is 15, height at the top is 2 squared, and height at the bottom, also known as speed at the bottom, final velocity is 4, and work out. So this is 240 plus 30 is equals to 120 and work done. So 240 plus 30 minus 120 is work done. So work done against resistance is 150 joules. Question number 2. The diagram shows a smooth ring R of mass m kgs. Let me label it. So weight should be mg. Threaded on a light inextensible string, a horizontal force of magnitude 2 newtons acts on R as shown in diagram. The ends of the strings are attached to fixed point A and B on the vertical wall. The part AR of the strings make an angle of 30 degrees with the vertical, and BR makes an angle of 40 degrees with the vertical. And the string is taut. The ring is in equilibrium. So find the tension in the string and find the value of M. Know one thing, when this is one string and it passes through the smooth ring, tension in both the sides is same, so we are writing just T and not T1 and T2. Now if we resolve these, this vertical portion is going to be T cos 40 and this horizontal part is going to be T sin of 40. On the upper half, this side is going to be T sin of 30 and this is going to be T cos of 30. Now I'm going to resolve it about this ring, about this given point. I'm writing the horizontal forces, that is T sin 30 away from the ring and T sin 40 away from the ring towards left hand side and on the opposite 2. So this is one of the equation. Let the other equation be in the vertical direction. So say the upward force is T cos 30 and there are two downward forces. One is T cos 40 and the weight plus mg. Now we will fill in some values. So let's take out T as common. This is sin 30 plus sin 40 is equals to 2 So T is equals to 2 divided by sine 30 plus sine 40, and T is equals to 1.75 newtons. Now I can substitute this value in the other equation to find M. So 1.75 into cos of 30 is equals to 1.75 into cos of 40 plus G is 10, so 10 M. So 1.75 cos 30 minus 1.75 cos of 40 is equals to 10M. And 10M comes out to be 0.17496, where M is equals to 0.017496 kgs, or approximately equal to 0.0175 kgs. And number 3, a block of mass 10 kgs is at rest on the rough plane inclined at 30 degrees to the horizontal. A force of 120 Newton is applied to the block at angle of 20 degrees above the line of greatest slope. There is a force resisting the motion of the block, and 200 joule of work is done against this force when the block has moved a distance of 5 meters up the plane from rest. So find the speed of the block when it has moved a distance of 5 meters up the plane from rest. So let's resolve these first. Weight is going to be 100 newtons. This angle right here is 30. This is 100 sine of 30, component of weight downwards. This is 100 cos of 30. And let's resolve this 120. Horizontal force would be 120 cos of 20, and vertical is 120 sine of 20. Now we know that it started at rest, so initial potential is 0, initial kinetic is 0, and work done by the applied force is force into distance. On the other hand, it have gained some kinetic energy, and the work done to move it 5 meters would include the potential energy and work done against resistance, which is already given 200, and force against this, that is distance of 5 into component of weight, that is 100 sine 30. So force, applied force is 120 cos of 20, and distance is 5. Kinetic energy is half mv square plus 200 plus 50. This is 250. Now we keep on simplifying. That is 563.8. Bring this 200 to left. Bring this 250 to left. And we are left with 1 by 2 into mass into velocity. Simplifying, we get 113.8 is equals to 5v square. So v square is equals to 113.8 by 5. V squared is equals to 22.76. Square root both sides. V is equals to 4.77 meters per second. Number 4. A particle P of mass 0.2 kgs lies at rest on a horizontal plane, rough horizontal plane. A horizontal force of 1.2 newtons is applied to P. Given that P is in limiting equilibrium, find the coefficient of friction between P and the plane. So this is the scenario, that this is the rough horizontal plane. Particle P of mass 0.2 kgs would make 2 Newton weight, and a force of 1.2 newtons is applied, and the frictional force should be in the opposite direction, and it is in limiting equilibrium, would mean that friction is equals to applied force. So mu r is equals to applied force where mu is unknown, r is 2, 1.2. So mu comes out to be 0.6. B part. Given instead that the coefficient of friction between P and the plane is 0.3. Coefficient of friction is now changing. This was the particle. Find the distance traveled by P in the third second of the motion. So it is moving to right with a force, applied force of 1.2, and friction should be, friction equals mu r, that is 0.3. Normal contact force is 2 newtons. So this is 0.6. Friction is 0.6. Now consider F equals MA. Net force 1.2 minus 0.6. Mass is 0.2. Acceleration is unknown. So 0.6 by 0.2, we get an acceleration of 3 meters per second square. And to find the distance in the third second, I'm finding the distance in first 2 seconds, that is ut plus half at squared. Initial velocity, it started at rest, so 0 plus half acceleration is 3. So in the first 2 seconds, distance traveled is 6 meters. Now let's find the distance traveled in first 3 seconds. So S3 should be ut plus half at squared. Initial velocity is 0, acceleration is 3, time is 3. So in first 3 seconds, total distance traveled is 13.5 meters. So S3 is 13.5, S2 is 6 meters. So this is the distance covered in the last third second. So distance in third second is equals to 13.5 minus 6, 7.5 meters. Question number 5. A particle A of mass 0.5 kg is projected vertically upwards from horizontal ground with a speed of 25 meters per second. Find the speed of A when it reaches the height of 20 meters above the ground. Let's use this equation. V square minus U square equals 2AS. Final velocity unknown. Initial velocity is 25. Acceleration is negative 10 as it is going against the gravity, and displacement is 20. So V square minus 625 is equals to minus 400. V square equals 625 minus 400. V square is equals to 225. Square root both sides. V is equals to 15 meters per second. 5b. When A reaches a height of 20 meters, it collides with a particle B of mass 0.3 kg, which is moving downwards. So this is the scenario. A is moving upwards and B is moving downwards in the same vertical line as A with speed 32.5 meters per second. In the collision between the two particles, B is brought to instantaneous rest. Show that the velocity of A immediately after the collision is 4.5 meters per second downwards. So we'll use a concept of momentum. Mass of A into velocity of A plus mass of B into velocity of B is equals to mass of A into velocity of A plus mass of B into velocity of B. U represents the initial velocities, V represents the final velocity. The mass of A is 0.5 and the velocity is 15 as found in the first part. Mass of B is 0.3 and velocity is given 32.5. Put a negative sign with it because it is downwards. Mass of A is 0.5 0.5, velocity of A unknown, and when B comes to rest, mass is this and velocity is 0. B was at rest. Now we simplify. 7.5 minus 9.75 is equals to 0.5 velocity of A plus 0. So minus 2.25 is equals to 0.5 velocity of A. Velocity of A is minus 2.25 divided by 0.5, and velocity of A is equals to negative 4.5 meters per second. So done. And speed could be written as 4.5 meters per second downwards. This negative sign shows you that the direction is downwards. Question 5C part. Find the time interval between A and B reaching the ground. You should assume that A does not bounce when it reaches the ground. Now this is the case. Particle A is coming down with the speed of 4.5 meters per second as found in B part, and particle B starts from rest. Speed is 0 meters per second as given in the B part. So displacement is equals to ut plus half at square. We already know that they collide with each other at a height of 20. Initial velocity for A is 4.5, time is unknown, half taking acceleration as 10 as it is in the direction of gravity, and we solve this equation. So you get 20 is equals to 4.5t plus 5t square. Rearrange 5t square plus 4.5t minus 20 is equals to 0 using quadratic formula. Minus b, this is 4.5 minus b plus minus square root b square minus 4 into a into c. Be careful with these signs. Over 2a, and we get 1.6 seconds and negative 2.5 second, which is obviously rejected. So final answer is 1.6 seconds for particle A. Now for particle B, S is equals to ut plus half at square, and displacement is again 20. Initial velocity is 0 plus half acceleration is 10 t squared. So 20 is equals to 5t square, 4 is equals to t square, t is equals to plus minus 2. We ignore the negative 2. So B takes 2 seconds to reach the ground and A takes 1.6 seconds. So difference in time is 2 minus 1.6, 0.4 seconds to reach the ground. Question number 6. A railway engine of mass 120,000 kgs is towing a coach of 60,000 kgs up a straight track inclined at an angle of alpha to the horizontal where sine alpha is 0.02. There is a light rigid coupling parallel to the track connecting the engine and coach. The driving force produced by the engine is 125,000 newtons, and the constant resistances to motion of 22,000 on engine and 13,000 on the coach. Find the acceleration of the engine and the tension in the coupling. So we'll first draw the scenario and label all the forces. So let this be the angle. This is the coach, and weight of the coach is given. Mass is 60,000. So weight is 60, 1, 2, 3 and another 0. Now we split them in two. This is going to be mg cos of angle. This is mg sine of angle. Now on the other end, when we talk about the engine, now mass is 120,000. So we write 120, 1, 2, 3 and another 0 for the weight. You split them, mg cos of angle, mg sine of angle. Now additional forces, we have a resistance of 13,000 on the coach. We have a resistance of 22,000 on the engine, and there is a coupling between them. So for the coach, tension would be upwards, for the engine tension would be downwards. And one more force, which is 125,000, that is driving force on the engine. Now let's make some equations for engine first. So for the engine, I know that the forward force is 125,000 and there are three resistive forces, 22T and mg sine alpha. So 22,000 minus the tension minus mg sine alpha, which is m is 120,000, g is 10, another 0 into sine alpha, which is 0.02. We'll plug it in and equals ma, net force. Now let's simplify this. This is 103,000 minus tension minus 120, 1, 2, 3, 4 into 0.02 equals mass is 120,000 into acceleration. So when we simplify this, we get 79,000 minus tension is equals to 120,000 times acceleration. Let this be equation 1. Now let's do the same for the coach. So we know for the coach, the forward force is tension only minus the resistive forces, that is 13,000, and the component of weight, mass into gravity. Mass is 60,000 into gravity, we add one more 0 and sine theta 0.02. On the other side, ma. So we simplify this to get T minus 25,000 is equals to 60,000 into acceleration, be equation 2. Now let's make T the subject. So that is 60,000 acceleration plus 25,000. Let this be equation 3 and I'm plugging in equation 3 in equation 1. So let that be 79,000 minus, in place of tension, I'm writing all of this, 60,000 A plus 25,000 is equals to 120,000 acceleration. Now 79 minus 25 is 54,000, and this negative 60,000 goes on the other side to make it 180,000 times acceleration. So acceleration is 54,000 divided by 180,000, and use your calculators to get 3 by 10, which is 0.3 meters per second square. So we're done with the acceleration. We can use this equation 3 to find the tension. So tension is equals to 60,000 times acceleration plus 25,000, that is 18,000 plus 25,000 leaves us with 43,000 Newton of tension in the coupling. Question 6, B part. At an instant when the engine is traveling at 30 meters per second, it comes to a section of track inclined upwards at an angle beta to the horizontal. The power produced by the engine is now 4500,000, and as a result the engine maintains a constant speed. Assuming that the resistance forces remains unchanged, find the value for beta. So if the forces remains unchanged, we are quickly splitting that up. This was the coach, weight, and the components split up. Engine and the components are splitting up. This was force of friction on coach, force of friction on engine. This is mg sine beta. This is mg sine beta, mg cos of beta, and mg cos of beta. And only one driving force upwards is force of driving, and the coupling tension upwards and tension downwards. Now we are going to solve for driving force first. Power is equals to force into velocity. Power is given 4500,000. Driving force is unknown. Velocity is 30 meters per second. So driving force is equals to, by 30, driving force comes out to be 150,000 newtons. So that is 150, 1, 2, 3 newtons. Now we write the equation. Because it is traveling with a constant speed, so it must be in equilibrium. So forward force is 150, 1, 2, 3, 150,000 minus first resistive force is this. You can copy the values from part A. This was 120, 1, 2, 3, another 0 for gravity, and sine beta, which is unknown, minus 22,000 resistive force on the engine. So only forward force is this driving force, one resistive, second resistive, third resistive is weight of the coach, that is mass 1, 2, 3, another 0 for gravity, and sine beta, and another resistive force is 13,000 newtons is equals to 0. You don't take this tension because forward backward they're cancelling each other. Now the only unknown is sine beta. Use your calculator to add up these three values and we get 115,123, and adding these two we get 180,123 sine of beta, and another 0 is equals to 0. So 115,000 is equals to 180,123 4 zeros sine of beta. 115,000 by 180,123 4 zeros is equals to sine beta, and we take sine inverse of 23 by 360. This is what we get when you use the calculator, and beta is equals to 3.663, approximately equal to 3.7 degrees. Number 7. A particle x travels in a straight line. The velocity of x at time t seconds after leaving a fixed point O is denoted by v meters per second, where v is equals to this. The acceleration x is 0 at t is equals to p, acceleration is 0, and t is equals to q, where p is less than q. Find the value of p and q. So we know velocity is equals to negative 0.1 t cube plus 1.8 t square minus 6t plus 5.6. So in order to find the acceleration, I'll have to derivate this equation, and we get the negative 0.3 t square plus 3.6 t minus 6. And we know that acceleration was 0. So we plug in 0, and negative 0.3 t square plus 3.6 t minus 6 dividing the whole equation with 0.3, negative 0.3 t square minus 12t plus 20 is equals to 0. And solving by midterm breaking, minus 2t minus 10t plus 20 is equals to 0. t minus 2 minus 10 t minus 2 and t minus 10. The other one is t minus 2. So t minus 10 is equals to 0. We get t is equals to 10. And t minus 2 is equals to 0. We get t is equals to 2. Where p was lesser than q, so p is equals to 2 and q is equals to 10 seconds. It is given that the velocity of x is 0 when t is equals to 14. Velocity is 0 when t is 14. Find the velocities of x at point t is equal to p and t is equal to q, and hence sketch the velocity time graph for the motion from 0 to 15. So equation of velocity, negative 0.1 t cube plus 1.8 t square minus 6 t plus 5.6. So we just plug in the values, minus 0.1 at 2 cube plus 1.82 squared minus 6 into 2 plus 5.6. Use the calculator and get the value. And second, when the time is 10 seconds, so negative 0.1 10 cube plus 1.8 10 square minus 6 into 10 plus 5.6, velocity is 25.6 meters per second. Now we have the velocities, we can sketch the graph. We know at 2 velocity is 0. We know at 14 the velocity is 0 as given in the question, and we've just found that at time 10 velocity is 25. So it is a sketch, and at time 0 when you plug in all these zeros you will get 5.6. So it starts from here somewhere, reaches 0, increases to 25.6, crosses the graph at 0 to 15, 0 at 14, and this is your sketch. So label the axis velocity in meters per second and time in seconds. Question 7 C part. Find the total distance traveled by x between time 0 and 15. So equation of velocity is minus 0.1 t cube plus 1.8 t squared minus 6t plus 5.6. In order to find the displacement, we need to integrate the given equation. So s is equals to integrating it, and from 0 to 2. We have these sections from 0 to 2, 2 to 14 and 14 to 15. So we're going to find the displacement individually and then add them. So negative 0.1 t cube plus 1.8 t square minus 6 t plus 5.6 dt. Integrating negative 0.1 t 4 by 4 plus 1.8 t cube by 3 minus 6 t square by 2 plus 5.6 t from 0 to 2. Now upper limit minus lower limit. Negative 0.1 into 2 raised to power 4 by 4 plus 1.8 into 2 raised to the power 3 by 3 minus 6 into 2 squared by 2 plus 5.6 into 2 minus lower limit. All these are t, that is going to be 0. So use your calculator to get 3.6 meters. So this is from 0 to 2. Now we go for 2 to 14. Okay, so displacement, it is already integrated. I'm just going to plug in these limits. So negative 0.1 t 4 by 4, copying the same equation, plus 1.8t cubed by 3 minus 6t squared by 2 plus 5.6t, and from 2 to 14. Now negative 0.114 raised to power 4 by 4 plus 1.814 raised to power 3 by 3 minus 6t 14 squared by 2 plus 5.6 into 14. Simplifying this 6 and 1.3 is your personal choice. Now upper limit minus lower limit. When we plug in 2, we already have that value, that is 3.6. So simplifying this, I get 176.4 minus 3.6 is 172.8 meters. Third one. Okay, the third section is going to be S is equals to the same equation, negative 0.1 t 4 by 4 plus 1.8 t cubed by 3 minus 6 t square by 2 plus 5.6 into t, and this time it is from 14 to 15. So upper limit negative 0.1 into 15 raised to power 4 by 4 plus 1.8 into 15 cubed by 3 minus 6 into 15 squared by 2 plus 5.6 into 15. This is the upper limit. Minus, when we plug in 14, we know we get 176.4. So it comes out to be 168.375 minus 176.4, and it is negative 8.025. This is just negative because it is going below the graph. So we'll change the sign and write it as 8.025 meters. Now the final displacement covered is 3.6, 172.8 and 8.025, leaving us with an answer of 184.425 meters. And we could also have done it from 0 to 14 and then from 14 to 15 rather than doing it in 3 phases. Thank you so much for watching. Don't forget to subscribe. Take care.